Happy to meet you all in this online forum. Maybe the last day of this particular paper on research methodology. Being the sixth day, we are going to discuss about the previous year UGC questions, covering these 6 different units, whatever we discussed in the last 2 days. Okay, starting from the reporting of your results, then statistical analysis, cyanometric and bibliometric studies, and the so-called impact metrics. That is what you're going to cover in this today's class. In fact, whatever questions we discussed in the previous class, I think I mailed to Manoj sir. I think he would be forwarding to all of you. The same way, today also I've got 2 PDF files. Okay, and I will mail these 2 PDF files to Manoj sir. I'm sure he will forward these 2 PDFs also to your registered mail ID. Okay, so that will not be a problem for you. Let's begin our discussion. We'll start from units 9.5, 9.6, and 9.10. Okay, and I have taken last 10 to 11 years UGC question papers. Let us see what kind of questions were asked in all these years. Fine. We'll start from June 2005. Which one of the following pairs is not correctly matched? The difference between the highest and lowest values of a variable. Range. The answer is correct. You know very well. Whenever you want to find out the range, you have to find out the highest number. You have to find out the lowest number of the series. If you find out the difference between the highest number and lowest number, that is termed as range. So A is correct. B. The value of a variable which divides the area under the frequency curve into 2 equal parts. So obviously it is median. So median is the middlemost point of a distribution. So median point will be there in such a position that you can see almost equal number of observations lying both on the left side and right side distribution. So median is right answer. Then C, the result when the sum of all the terms in the series is divided by the number of items in the series. Exactly, it is mean. Some people say average, some say arithmetic mean. So total divided by number of observation. So right. So A, B, C, all the 3 statements are correctly matched. So no problem. The last one, the value of a variable for which the frequency is maximum. So the answer, correct answer is mode. See, you know very well. But here a given probability. So D is the wrong answer. Fine. Okay. So all 3 statements are right. Next question. So during all these examinations, not even a single question was asked from this particular 3 units. Okay. June 2008, mean, median, and mode are measures of deviation, ways of sampling, measures of this not control tendency, central tendency. E. Okay. I'm sorry. This is central. Measures of central tendency, because mean, median, and mode, all these 3 values would like to give the summary of the distribution. If you have collected data from some 20 students or 1000 students, you can find out a single score by which you can express the how the data is centering around the middlemost observations of your data. So all the mean, median, mode are measures of central tendency. Okay, fine. December 2008, no question. December 2009, no question. Then June 2010. See, median is simply the middle value when the data have been arranged in ascending or descending order. That is right. No need for any explanation. Median refers to the middle value in the distribution. So both A and R are true. Fine. Again, same question. Mean, median, and mode are measures of central tendency. We talk about measure of deviation. So we have got something called range, we have interquartile range, we have variance, we have standard deviation, we have coefficient of variation. So these are all the measures of deviation, wherein we are trying to find out to what extent your collected data, your observation is away from the mean score. Okay, that is measures of dispersion. Okay, or deviation, whatever you call. Then June 2011 and December 2011, no question. December 2012, the high-square technique is used to compare the observed data with that of dash. So as I told you, In chi-square, we are always comparing two things: the observed data and expected data. Okay, so we are inputting observed data into a software like SPSS. SPSS will calculate the expected data, and observed data and expected data both will be compared, and then we will be trying to see whether is there any association between these two variables. Fine. See, it's very simple. Expected data is very simple. For example, you take boys and girls. You feel that if there is no difference between the boys and girls, if you feel so, then the number of appams they take in for a morning breakfast will be same. Okay, there's no difference. If there is a difference, that will be seen in the data collected. You might have gone to a college, you might have visited some 100 boys and 100 girls. You would have asked them how many appams you take for your breakfast. You might have collected the data. So your collected data will be compared with the expected data. Then the chi-square tells you whether is there any association between the gender of the respondents and number of appams they eat for the breakfast. Something like that. Okay, fine. In December 2012, match the following, same thing. So mean is the average. Okay, I did not repeat it. Mode, most frequently occurring value is called mode. Median is the middle value, and standard deviation is a measure of dispersion. Okay, whatever we have discussed, it is given the form of a matching type question. Fine, let us move further. June 2013, a graphical representation using symbols to represent operations, data, flow, etc. is what kind of chart is this? It is called a flow chart. You might have studied in computer science and all, where we prepare a flow chart to decide upon the steps to be involved in solving a particular problem. Fine. How we are using all kinds of symbols. We are using all kinds of some kind of rectangles, arrows and all to be shown, no? To tell us how the data is flowing from one place to another place. If the data is blocked, how it is moving to another place. So that kind of chart is called a flow chart. You know that very well. Okay, fine. Next one, systematic and coefficient use of statistical tools in research helps in precise interpretation of research results. That is true. So if you are able to use very systematic and efficiently the statistical tools available, then you will be able to exactly interpret your research results. So A is true. What about R? Statistical tools cannot give specific explanations of the data. So this is false, because statistical tools we are using only for the purpose of very specifically explain what the data we have collected. So A is true, but R is false. Okay, fine. June 2013, let us match the following. Okay, here amenable to further algebraic treatment. That means there is a number, okay, which can be subjected to further treatment in other statistical tools. So what is the answer? Arithmetic mean, that is average. So if you have calculated the mean can be used in many other tests. Whether you talk about paired sample t-test, independent sample t-test, or one-way ANOVA or two-way ANOVA, in all these cases, Z test, in all these cases, we are comparing only the means. So mean is a data which can be further put into various algebraic treatment. So the answer for 1 is 4, arithmetic means. Then estimated without knowing values of extreme item. See, there is a value we are trying to find out, but we are not bothered about the extreme cases. What is that? See, that is called a median. That is called a median. See, for example, you collected data from 100 students, the height of 100 students. You arrange all the 100 observations in the decreasing order or increasing order. Okay. So you are not bothering about the lowest heights. You are not bothered about the highest heights. You simply find out the middle value and report. That is called a median. So estimated without knowing values of the extreme item, that is median. Okay. Then mathematically and logically incorrect. Okay. Which is out of these 4, which one is mathematically and logically incorrect? It is mean deviation. Okay, I'll explain that. Find the dispersion does not cover all items of a series. Okay, so when you talk about data dispersion, as I told you, you can make use of range, you can make use of variance, You can make use of interquartile deviation, interquartile range, or you can make use of standard deviation or coefficient of variation. So all these measures can be used to check to what extent your data is moving away or it is away from the mean score of the data. Fine. See, when you talk about interquartile deviation, for example, as I told you, you have collected data from 100 students. Okay. You arrange all the 100 points in the decreasing or increasing order. Okay. So what you are supposed to do is that you have to divide this data into 4 quarters. First 25%, second 25%, third 25%, and last 25%. Fine. So if you have arranged all your data in the increasing order, then the first 25% of your data will have all the lowest values. And the fourth quarter will contain all the highest values. So when you are trying to find out the interquartile deviation or interquartile range, we are just removing the first 25%. We are removing the last 25%. We are taking only the middle 50% of your data. Okay. Now what you have done? We have taken the middlemost 50 observations. Among these 50 observations, find out the highest score, find out the lowest score. The difference between highest and the lowest score of this 50 middle observations is equal to interquartile range. Okay, that is why they say that the dispersion does not cover all items of a series, because we are omitting the first quartile, we are omitting the last quartile, we are taking into consideration only the second and third quartile of any distribution. Fine. So that is called interquartile distribution or interquartile range. Then why do we say that mathematically and logically mean deviation is incorrect? So it's very simple. You know very well. How do you calculate mean deviation or standard deviation? It's very simple. We take all the observed values, first column. Second column, we minus the observed values from the mean score. Okay. And you will get variance. Fine. I'm sorry, you get deviation. You get deviance. So the deviance can be either plus figured or minus figured. Okay. So what you do, you multiply the deviance by itself. Okay. So what you get, you will get the squared value of deviance. Okay. If you add, why do we multiply it? Because if you don't multiply, without multiplying it by the same value, if you are adding all the answers you got, what is the answer? The observed value minus mean score. Whatever answer you get, if you total all these things, you will get only 0. Okay. In order to escape from this problem only, it is squared, you get sum of squared, then you divide by n minus 1, you get variance, you find out the square root of variance, you will get standard deviation. So when you say that mean deviation, when you're simply calculating without multiplying, the total of all the answers will be 0. So that is what we say it is mathematically and logically incorrect. Okay. Maybe you can just go through my explanation. Fine. Good. Then September 2013, match the following. Here they have given left side bibliometric laws and right side you have to match them. Okay. Let us see one by one. I think this is very clear to you. 1 is to n square. So that is nothing but Bradford's law of scattering, wherein we are dividing all the journals of a particular field into 3 groups. Fine. Then comes Pareto principle. I was explaining yesterday. 80 is to 20 principle. That means 80% of papers in a particular subject would have been contributed by 20% of authors of the field, or 80% of wealth of the country will be owned by 20% of the people. That's what Pareto principle. So these two are very clear. What about first one? F into R is equal to K. I think this R, I don't know whether it has got any valid or not, but F into R is equal to K. I think we already studied. K means constant. F means frequency of a particular word as it appears in a text, multiplied by the rank whatever we have assigned to that particular word in the text. So frequency into rank is equal to constant. So that is Zipf's law of word frequency, you know very well. So which is the left one? The left one is load cost, law of scientific productivity, which says that x to square of n, y is equal to c. Okay, here n stands for number of contributions, X stands for X stands for number of papers. C equal to constant. Y means the relative frequency of authors publishing in that particular field of subject. Okay, so I think if you are thorough with one or two formulas, based on that you can find out, you can guess the answers of other formula also. Fine, no problem. September 2013, the correlation coefficient is, see, when I was talking about correlation, I told you that correlation is always about the linear relationship. Okay, when you talk about Pearson correlation coefficient, we are talking about only the linear relationship that exists between the variables. That means when one variable is increasing, other also will increase. When one is decreasing, other also will decrease. Or when one is increasing, the other will decrease. That is called linear relationship. Okay, so the correlation coefficient is used to measure the linear relationship between two variables. And when you are measuring these variables, you can find out how strong is a relationship between these two variables. So based on the R value, if you conduct Spearman rank correlation, or if you conduct Pearson coefficient correlation, you go to R score. You can find out, depending on the R score, you can find out how close, how strong the relationship between two variables are. So both A and C can be taken as the answers for this question. Fine. Next one, once again, match the following. Here, let me start from very simple one. Okay, this is a very simple one. Sigma x divided by n, total of the observations divided by number of observations. So you know very well, that's nothing but mean score. Okay, total of observations divided by number of observations, you get mean. Very simple one. Then comes the C. It's very simple one. R minus 1, C minus 1. Okay, see, whenever you are calculating high square statistics, or whenever you're using Kruskal-Wallis test, so they always talk about degree of freedom. Okay, so you need to calculate degree of freedom. See, degree of freedom can be calculated in two different occasions. For example, you have collected data from some 100 respondents on how many hours they spend on watching movie every week. Okay, you collect data from 100 respondents. So what is the degree of freedom? Degree of freedom is equal to total observations, that is n minus 1. N minus 1 is the degree of freedom when you are having only one set of data. Fine. If you are having a cross tabulation data, you are having two variables. You have arranged your table in a 2 into 2 structure. For example, column you have boys, girls. Fine. In the row, you're having whether they like puttu and kadala curry, or they don't like puttu and kadala curry. So 2 into 2. So when you're having this kind of table, how to calculate degree of freedom? The formula is row minus 1 into column minus 1. This is a formula to calculate degree of freedom. So answer for C is 1, degree of freedom. Fine. Okay. And next is a very simple one again. See, this O minus E will tell you. Okay. O stands for observed value. E stands for expected value. I think you might have guessed the answer. Okay, yes, you are right. It's none other than chi-square. Chi-square is a tool wherein we are talking about observed values and expected values. So A, answer for A is 4 chi-square. What is left out? This is standard deviation. Okay, what is standard deviation? Sigma of x squared. Okay, you are calculating x squared. Then you are totaling all the x squared. You get sigma x squared divided by n. You get the answer. Whatever answer that is variance you got, you have to find out the square root of variance. You will get standard deviation. So D stands for 2 standard deviation. Fine. Very simple. You have to remember this. O stands for observed. E stands for expected. Such kind of things, if you remember, it's very easy to match these formulae. Okay, fine. Then 2013 December, chi-square is an important non-parametric test which does not require rigid assumptions in respect of the type of population being studied. So exactly right. As I told you, we have two different types of statistical tests: parametric, non-parametric. Okay, under non-parametric, we are having chi-square. we are having Mann-Whitney, we are having Kruskal-Wallis test, and we have Spearman rank correlation. All those things are there. The non-parametric tests, they are not rigid. Parametric tests are very rigid because parametric tests are powerful and they say that data should be in numbers. The data should be normally distributed. So such kind of rigid regulations are there, assumptions are there. But in the case of non-parametric tests, these assumptions, rigid rules are not there. So assertion A is correct. Let us go to R. Since chi-square is a non-parametric test, it requires only the degree of freedom. So right, I told you, no. So in the case of chi-square, we calculate degree of freedom. So both A and R are correct. Fine. Next question. A chart in which some figures are broken down into its constituent parts is, you know, which pie chart. Very simple. We used to say chapati chart. Okay, you take on chapati, you divide it into various parts. It's called a pie chart. Okay. Bar chart, you know, I think I had shown you in my class. What about this column chart and band chart? Okay, let us see them. So this is a band chart. See, band chart is it's a kind of line chart. Okay, it's a line chart. But here we are going to have some added shaded areas. See, whenever you want to show the upper and the lower boundaries of the defined data range. See, you collect the data from some customers. Okay, and you might have fixed what is the lower boundary, what is the upper boundary, what is the middle boundary. So apart from these line graphs, we are having some shaded areas in 3 different colors to show 3 different boundaries of the defined data ranges of your research work. So this kind of line chart is called as band chart, which is also called as range chart, high-low line chart, or corridor chart. Okay, remember all these terms. Okay, fine. Then what about column chart? So it's a very, very simple one. Here, each and every column is having rectangle. The height of the rectangle will be proportionate to the values it represents. That's it. For example, if you take Coke, 3 answers are there. The rectangle which is taller up will tell you that is the one having the highest frequency. Fine. So these kinds of rectangular bars which are kept together to represent individual variable is called as column chart. Okay, fine. Very simple. It's also called as vertical bar chart. The other name for column charts is vertical bar charts. Okay, fine. Let us move on. This is a kind of a question. I had a kind of confusion because this is related to bibliometrics, but still I tried. There are some hiccups in this question. Okay, maybe let us see. Measure of similarity between 2 documents. In general, when you want to see what kind of similarity is there between 2 research papers, 2 documents, that is called coefficient of association. Fine. In general, you see. But when you want to find out the similarity measure based on overlap in terms between 2 documents, you take 2 documents and you see what are the various terms that are overlapping in these 2 documents. Okay, so that kind of thing is called proportion of coefficient association. Proportion of, in the coefficient association, we are talking about only those terms that are overlapping in these 2 texts. That is called proportion of coefficient association. Fine. Then comes the document similarity based solely on the occurrence of words. We're just checking whether the same words are occurring here and there. That is called lexical similarity. You know, lexical means study of lexicology, study of words and all. No, so the study on when similar words are appearing in both the texts or not, you're studying. So that is called lexical similarity. Fine. The last one, which I tried, but I was not able to get clearance anywhere. Similarity measure, which is based on the city block distance between 2 documents. So they say it is rectangular distance coefficient. So though I tried a bit, I was not able to get any kind of explanation for this particular option. So you can just try in Google. Okay, fine. Next one, mean, median, and mode are the simple techniques to get exact averages for data analysis in research. Yes, right. Okay, mean, median, mode are displaying the exact averages. These are the well accepted statistical techniques of research for data analysis of historical data. See, when you talk about historical data, nowhere we are going to talk about mean, median, mode. So A is correct, but R is wrong. Okay, fine. Then, if we plot recall and precision on X and Y axis, okay, you take a graph sheet, you take X and Y axis, you have recall value and precision value. Whatever graph you get, that is called as what? So, you know, I have been telling you, recall and precision will always have an inverse relationship. When recall is higher, precision will be less. When precision is higher, recall will be less. So this kind of inverse relationship, no, you will kind of a sloping curve, no, that is called a hyperbola. That's called hyperbola. How will it look like? It will look like this way. Okay. See, this is a precision. When precision is higher, the most, you can see the recall is less. When precision is higher, recall is less. When recall is increasing, from 0.2 to 0.4, 0.6, 0.8, 0.1, automatically the precision has come down from 1 to 0.02. Fine. So this kind of inverse relationship shown by a sloping curve is called as hyperbola. Okay, fine. Next, match the following. Okay, here they are given some statistical measures. Let us see them. One is skewness. See, skewness is always talking about structure of distribution. Okay, how structured your data is, whether it is having a long peak, or it is having a left side peak, or it is having a right side peak. See, if you are, for example, you have collected data from some 100 students. Okay, you got the mean score. If most of your data are lesser than mean, then you will have a left-tailed skewness. Okay, data will be left-sided skewness. If a good number of observations, their means are more than the average score, then you will have a right-tailed skewness. Fine. But if most of the observations are revolving around mean, you have what? Less number of observations which are less than mean, and you're having less number of observations which are more than mean. So that is called a perfect skewness, where you can see a bell-shaped curve in a histogram. Okay, so skewness talks about structure of distribution. Okay, fine. What about modality? See, modality means numbers are frequently appearing variables. Okay, modality means see, when you draw a histogram for a data, how many peaks your data is having. For example, if you take a typically normally distributed data, a histogram with a bell-shaped curve, it will have only one peak. That is called unimodal distribution. Only one peak will be there. But in some cases, we can have either bimodal distribution, where you can have two peaks. Okay, when you collect data from different people, no, if you calculate the scores, no, you arrange them in the form of a histogram, there will be two peaks. 2 points, you should be very having a lot of observations, two peaks. Sometimes multimodals, many peaks may be the data. So modality talks about how many peaks are there in your data, number of frequently appearing variables. Okay, fine. I have given some explanation for modality, and I have given here what is modality, what is bimodal, what is multimodal. You can read it. Fine. Then comes a correlation. Very simple. Correlation, always we are trying to find out the degree of association between two or more variables. Okay, we are trying to find out the association between variables. Fine. What about F distribution? See, in statistics we have got different types of distribution. We have got discrete distribution, continuous distribution, normal distribution. We have F distribution. We have high-square distribution. Many distributions are there. Many models are there. F distribution is nothing but the ratio of two high-square variables. Okay, because they say that both F distribution and the high-square distribution both have a similar kind of skewed distribution of probabilities. But what is the difference between these two? In the case of high-square distribution, we are talking about only one set of variables, so we'll have only 1 degree of freedom for our analysis. But in the case of F distribution, we'll have many events, so that we'll have not only 1 degree of freedom, we'll have more than 1 degree of freedom. Otherwise, when you have got couple of chi-square distribution, that is called as F distribution. Okay, fine. Next question, which are the following are statistical programming software? You know very well, ESP is software. Same way, even GAUS and essays are also statistical softwares. This SLIM, actually it is a software lifecycle management software which can be used to estimate the projects. The other three things, SPSS, GAUS is also an interactive environment which is meant for mathematical and statistical analysis. It is a matrix programming language, and it has got three different categories of functions: mathematical, statistical, and scientific. The same way, SAS stands for Statistical Analysis System, which was developed by a private company called SAS Institute. It is a command-driven software package. So out of these three, only SLIM is not the statistical package. Fine. Next one, scale types. Okay. Likert scale. So what is Likert scale? It's only Likert scale is a summation scale. For example, when you want to measure the work efficiency of the laborers, you ask some 5 or 6 questions. And all these 6 questions combinedly, they will explain the work efficiency of the laborers. So it's a summation scale. Chi-square. What is the purpose of chi-square? What is the purpose of ANOVA? Okay. Test of validity. What is the test of validity? It's a test of measurement. Okay. What is a measurement scale? You may have a questionnaire or a schedule or an interview schedule or rating schedule. You may have some kind of a tool, a measurement tool. How can we test this measurement tool? I told you long back in my previous classes, there is something called reliability. There is something called validity. So validity of your measurement tool. To what extent your tool is valid both internally and externally. Internally means how reliable it is. Externally means how extent it can be applied in other situation. So test of validity is an example of test of measurement. That is okay. What about chi-square? See, test of significance of difference between the variables. Here test of significance. Okay. So chi-square, we study the test of significance between two variables, ordinal and nominal variables, or two ordinal variables. ANOVA, we test the significance of difference between variables. You take one independent variable, one dependent variable, and we check whether is there any difference between independent variables on the dependent variable. So that is called ANOVA. There is a one-way ANOVA, a two-way ANOVA, all the same. Fine, good. Next one. Types of data. I told you about different types of data. Nominal data. So what is a nominal data? I told you classification or grouping, categorical data. So nominal data can be gender details of library users. So we are grouping the users into male and female. This is a nominal data. We are nominating. Fine. Then comes ordinal data. I told you ordinal means ranking. You are going to rank the data. It's called ordinal data. So what is the answer? Ranking of library services by users. It's an ordinal data. How do they rank? Highly satisfied, least satisfied. Strongly agree, strongly disagree. That way. Then comes interval data and ratio data. Fine. So interval data can be something like level of satisfaction regarding library facilities. Why we say it is a interval data? Because this data will not have a true 0 point. Okay, we talk about level of satisfaction. There is no something called, there's nothing called a true 0 point. You cannot apply a number called 0 there. That's the interval data. What is the ratio data? Frequency of use of internet by different user groups. How frequently users are using the internet. It can be 10 times a day or 20 times a day or 0 time a day. Okay, if a user says that I have only 0 frequency, it means that he has not visited the library to make use of internet in that particular day or week. So there is a true 0 is absolute 0 is available. So this data is ratio data. Fine. There are 4 different types of measurement data. Next one, you have to match the various charts. Histogram, I told you it is about the frequency distribution. Okay. You can have frequency distribution shown in histogram. Then bar charts, it's called length of the bar. You got different length of bars in bar chart. Then pie chart, data in circle. You take a circle, you divide it into various fractions. That is a pie chart. Then pictogram is a chart where we are using signs and symbols. That is, we are using pictures to represent the data. For example, these are two examples for pictogram. So January month, how many apples are sold? 10 apples. Okay. March, 25 apples. Okay. So pictures are used to represent the data. It's called pictogram. Fine. Good. Then once again a match. So sample, variable, range, and standard deviation. Let us see one by one. What is a variable? It can be height or weight. So height is a variable, weight is a variable. Anything which varies from one person to another person, one case to another case called variable. Okay, height, weights are variables. What is a range? Difference in score distribution. If you take a score of data, observe data, collected data, highest score, lowest score, find the difference, that's called range. So difference in score distribution is called as range. What about standard deviation? Exactly as I told you, square root of variance. You find out the deviance. From deviance, you calculate the variance. From the variance, if you find out the square root of variance, that becomes standard deviation. So we got the answers for three things. What is the fourth one? Sample. That's what is sampling technique. Cluster sampling is a sampling technique. I think things are matched. Next one. Which are the following is a measure of dispersion? Okay, with a geometric mean, median, mode, or root mean square deviation. See, please understand, mean, median, mode, all these are measures of central tendency. Okay, only this root mean square deviation, only this standard deviation is called as measure of dispersion. Okay, fine. Once again, question on various scales. Okay, we'll see. Nominal scale, what it does, it classifies objects and observations like male and female. Okay, UGPG, classifies objects. What about ordinal scales? It is ranking, involves judges to rank items into categories. Fine. What about the differential scale? It places events in order and exhibits their relation. I think you remember differential scale where in order to tell about a particular item, they got a lot of statements. Each statement all are related. They are giving some marks and the respondents will select the statement based on their importance. Okay, that is called differential scale. The ratio scale represent the actual amount of variable. Okay, how many kilometers he has run. Okay, what is his height? How many questions he left unanswered? See, actual amount of variable called ratio scale. I think it's clear. Positive correlation occurs when you have positive correlation when two variables move in the same direction. Okay, number of library users is increasing. Other side, the number of library books borrowed is increasing. That is called same level direction, positive correlation. Fine, good. So negative correlation means when one variable is increasing, other variable will be decreasing. That is called negative correlation. Fine, okay. Then, which are the following are non-parametric tests? So please understand, ANOVA and Z test are parametric tests. Spearman correlation coefficient and chi-square are non-parametric tests. Okay. See, if your data is in numbers and if they are normally distributed, you can conduct Pearson coefficient correlation. If your data is ranked data, it's not the numerical data, then you can go for Spearman rank correlation. So B and D are non-parametric tests. Okay, fine. Then mean is a measure of dispersion. Okay, it is false because mean is a measure of central tendency. The mean is based on every observation and is representative of the whole population. Correct. So A is wrong, R is correct. Next one, a probability which is associated with the occurrence of an event is expressed as a number between. See, if you toss a coin, no, what is the probability? Either it will go for 0 or 1. That means, so what is the probability of a particular event to take place? It may take place, it may not take place. If it takes place, it is represented as 1. If it doesn't take place, that is represented as 0. Okay, fine. Identify the independent variables. I think we already discussed this question. Okay, I think I did not repeat it. I think by mistake I have duplicated this. Chi-square test is used by researchers to test which of the following. Okay, so chi-square is used for two purposes, as I told you. One is to check the goodness of fit of data. Okay, how fit your data is to a specific criteria. First purpose. Second purpose, to measure the association, significant association that may exist between two variables. Okay, these are two purposes of chi-square test. Let us put the answers from here. Test the significance of population variance. I told you, no, the example of percentage of people living in foreign countries. 40% Keralites, 40% are South Indians, 20% North Indians. Okay, whether this is true, this is fitting with the data what you have observed. You can conduct chi-square test of goodness of fit. Goodness of fit. And secondly, test of significance of association between two attributes. When you take two attributes, if you want to find out the association between those two attributes, you can conduct a chi-square test. These are the two basic purposes any chi-square test may serve you. Okay, fine. Then, researchers in the behavioral sciences can describe variables in ratio form. I'm sorry, in behavioral sciences, we have only nominal data, ordinal data, ranking systems. We don't have pure answers. Okay, how much you like Rajinikanth, how much you like Mohanlal. So we cannot have a very precise measurement of these kinds of things. So A is false. Ratio scales have an absolute or true zero measurement. That is true. Okay, that's what I'm discussing. Then, who among the following have developed the initial version of SPSS? A, B, C. Remember the names. Fine. Who has developed Bibliography? I told you, only person of Sweden. Other people, they developed some amount, something else. They have developed some management theories. Only person of Sweden has developed Bibliography, a free software. Okay. Then, which are the following consist of a series of rectangles drawn next to each other without any space between them, each representing the frequency of a category or subcategory. Okay. See, if you take a pie diagram, that is a kind of a circle. If you take a line diagram, there will be a gap in between the lines. Okay. If you take cumulative frequency polygon, that is called ogive. I think I told you what is ogive. What are two different types of ogive curves? So histogram is a chart where we are drawing the rectangles drawn next to each other without any space in between them, and each represents a particular frequency. Fine. Okay. Then identify the frequency of occurrence and the analysis of co-occurrence of descriptors. See, descriptors are nothing but keywords what you assign to documents. I think we studied. So if you analyze the occurrence and co-occurrence of keywords, that is called co-word analysis. Okay, please understand. Co-word analysis. Who created R statistics? Rose Inaka and Robert Gentleman from Bell Laboratories. You know that? From the following, identify the non-parametric test or hypothesis. So out of these, which are the non-parametric? So you know very well, F test is a parametric test. Okay. I-square is a non-parametric test. Okay. I-square is a non-parametric. What about signed rank test and the rank sum test? Please understand. Signed rank test is also called as Wilcoxon signed rank test. Okay. See, paired sample t-test is a parametric test. Its equivalent, Wilcoxon signed rank test is a non-parametric. So signed rank test is a non-parametric test. Then rank sum test, you would have heard about Mann-Whitney U test, which is also called as Mann-Whitney rank sum test. So Mann-Whitney test, Wilcoxon signed rank test, chi-square test, A, C, D, all the three are non-parametric test or hypothesis. Okay, fine. That's it. Others are very simple questions, not from UGC examinations. Something like first electronic spreadsheet, popular spreadsheet when DOS was there, and when SPSS was introduced, and when it was acquired by IBM, when it was renamed as IBM SPSS, and from which version of programming language R was developed, in which year R was released, in which year the stable version of R was released, and regression is about cause and effect thing, and which are all the statistical tools used for testing hypothesis. All the tests, F test, chi-square test, T test, all are used for testing hypothesis. So that's about the first PDF file. Let me start presenting second PDF file. Before that, let me ask you whether do you have any question on the questions we have been discussing the last 45 minutes. Any question, please?
No, sir. No.
Okay.
No, sir.
Okay, thank you. And let me proceed with the next set of questions. Maybe at the end of this round of questions, if there is any question, you can always ask. Absolutely no problem. Your doubts can be clarified. Units 9.7, 9.8, and 9.9. Okay. And this question is asked in many number of years. Please make a clear understanding of this particular matching question. IBID, I told you, see, you are writing a reference. For example, you have taken few points from one paper. From the same paper, if you are taking one more point immediately, okay, you can use IBID. So you need not write the full reference again and again. Instead of writing the full reference once again, first time you write the full reference. Second time, if you are using the same reference, you can write IBID. So same reference cited immediately above. That is called IBID. What is VIDE? It stands for C, wide, through this. Okay. What about LOC and OP.CIT? Please make a clear difference between these two items. See, LOC means the same place cited, the same page, the same reference, the same page, but there is a gap. There is an interference between two variables, two references. You are using one reference, first reference, you are using another reference, a second reference, and as a third reference, you want to use the first reference once again. The same page, you can make use of LOC.CIT. But if it's not from the same page, but from the same reference, you can make use of OP.CIT. This is asked in 3 or 4 times, so you can please have a clear-cut understanding of these 4 terms. Okay, fine. Next one, Zipf's law. Okay, Zipf's law, it talks about, you know very well, it talks about word frequency, how frequently words are appearing in a text. Low-cost law, we talk about author productivity. Bradford's law, we talk about scattering of journals in a particular discipline. Eugene Garfield, the father of citation. It is he who developed impact factor. I think we discussed impact factor, the average citations to the journals in the recent 2 years. Impact factor, fine. Next one, which of the following would be the correct chronological sequence? I have given years here. Librometry 1948 by SRR. Bibliometrics 1969 by Alan Pritchard. Informatics 1979, Otto Nachi. Webometrics 1997 by Almin and Ingwersen. This is the order in which these bibliometrics topics evolved over a period of time. In these years, no question. Okay. December 2008, same question. So Bradford's law, scattering. Zipf's law, word frequency. Low-cost law, author productivity. And Scopus is the citation indexing. You know very well. Scopus is the citation database. Web of Science, citation database. Google Scholar, citation database. Fine. Okay. Bibliography coupling is needed too. Okay. What for? Bibliography compilation. Okay. When you are compiling bibliography, you talk about bibliography coupling. So always there is a confusion between these two terms. Bibliographical coupling and co-citation. What is the difference between these two exactly? You just see this graph, you'll understand it. See, for example, there are 2 papers, P1 and P2. Okay. So P1 cites P3, P2 cites P3. That is, paper P3 is found in the list of reference of P1 and P2. So both P1 and P2 are quoting or referring P3. So P1 and P2 are having bibliographic coupling. Clear? Fine. What about co-citation? For example, if you take a paper called P3 and if you check the list of references, these P4 and P5 are always quoted together. So these P4 and P5 are cited together in P3. So that means P4 and P5 are co-cited. Fine. That's the difference between bibliographic coupling and co-citation. Fine. Okay. What is the order of items in the research report? You know very well. We have a title page first. Then we have table of contents. We have text, maybe in 3 or 4 or 5 chapters. Then comes appendices. That is the order. You know that. Which bibliometric law describes the frequency of publication by authors in a given field. You know, Lodka's law, and I tell you, it's very clear. When a source referred to once in a footnote is referred to again, and between them no other reference intervenes, then the footnote uses the abbreviation IBID. I told you, no, same reference you're using once again without any gap in between. You can make use of IBID. Okay, fine. The term bibliometrics was first used by Alan Pritchard. Alan Kent, you know, is a very popular person for Encyclopedia of Library and Information Science. He's editor of Encyclopedia. Iesi Foskett, you know very well, the book which revolutionized self-arrangement libraries. A book written by him, Subject Approached Information, okay, by Iesi Foskett. Then next, half-life in information science relates to, see, in information science, we use the word half-life to mean rate of obsolescence, okay, rate of obsolescence of a piece of literature or a book or a journal or any kind of literary output. Okay, that means what is the half-life? Half-life means half the active life. See, what is the active life of a particular research paper or a book or a library resource? Okay, if you take a library resource, we talk in terms of how many people are using it. If you take a research paper, we talk about how many citations are received by that particular paper. Based on the usage, based on the citations, we decide the half-life of a particular field or particular journal article. Let us give an example. For example, in 1994, one article research paper was published. Okay, from 1995 onwards, it started getting citations. Okay, from 1995 to 2010, all the 16 years it was getting citations. After that, no citation for that particular research paper. Now you want to find out what is the half-life of this particular research paper. You see, 16 years, how many citations? 83 citations. This one research paper has received 83 citations in the span of 16 years. You have to find out the median. So what is the half of total citations? 42 citations. Okay, 42, 41 and half, we'll make it 43. So 43 citations are the half of the total citations received by this paper. So this paper has received 43 citations, half of the citations in how many years? You start from the first year, 9 plus 6 plus 7 plus 6 plus 7 plus 7. If you take first 6 years, within first 6 years of its publication, the paper has received half of its total citation. So 6 years is taken as the half-life period of this paper. After 6 years, the paper has started reaching its obsolescence. It has started decreasing its importance. Fine. That is what half-life is all about. And if you can just read, I have given a clear-cut explanation for calculating half-life here. Fine. Zipf's law is dealing with very simple frequency of occurrence of words in a text. It's repeated a good number of times. Arrange the following according to their year of development. I have given years. 5 laws of library science was published in 1931. Lodka's law was proposed in 1926. Bradford's law of scattering 1934. Zipf's law in 1949. You can arrange them. Okay, fine. Same question. I think I did not repeat this. Let me move on further. Web of Science is what? It is a citation index. Okay, we have got different kinds of indexes. We have got the full text index. We have got bibliographical index. We have got citation index. See, Web of Science is citation index where we can find out which later documents are citing the which earlier document. So this linkage is given in citation indexes. Web of Science is a popular citation index. Okay, fine. Same thing. Let us match these things. See, Eugene Garfield is known for citation indexing, so there's no doubt in it. And Bradford, we talk about distribution of articles published in periodicals. Lodka, we talk about scientific productivity of author. Zipf's law, we talk about frequency of word occurrence in a text. Okay. Zotero, you know, it is a reference management system where you can go and generate in-text citation. You can create list of references in more than 1,000, 2,000 reference styles. It is a reference management system. Fine. Impact factors devised by, as I told you, Eugene Garfield, the father of citation indexing, who was behind the establishment of Iesi, Institute of Scientific Information, which had started Science Citation Index, Social Science Citation Index, Arts and Humanities Citation Index, which was then merged into form Web of Science long back in 1997. So Eugene Garfield is a person who devised impact factor for measuring the relative importance of journals. Fine. Okay. Limitations of bibliometrics. So what are the problems with bibliometrics? So bibliometrics, we are just describing text. We are not bothered about what those texts mean, in what context those texts were used. One problem with bibliometrics. And secondly, always there is citation bias. Okay, for example, I will always cite my research supervisor. My supervisor will always cite his friends. I will cite you, you cite me. So that kind of bias is always there in citation. These are the problems in bibliometric or scientific studies. Fine. Next one, the alternatives and modifications to Hutch index. See, when people felt that Hutch index is not sufficiently portraying the research productivity or impact of the research productivity, they went for I-10 index. I told you, no, how many papers have got at least 10 citation. I-10, which was formulated by Google Scholar. And second one is pure Hutch index. Okay, it was developed by another group of people called, they say it's a pure Hutch index. Here, they take into consideration the number of authors involved in making the paper and what is the relative position of each author in the list of authors. If there are 3 authors, whether your name is listed as the first author or second author or third author, how many authors are there in the particular paper? Taking all these things into consideration, then they will calculate Hutch index. That is called pure Hutch index. Fine. And these two, Scimago Journal Rank, it is a freely available tool to measure the importance relative citation effect of journals from Scopus. European impact factor is the impact factor. So the answer is I-10 index and pure Hutch index. Fine. Then technical writing standards, style manuals and citation standards are very essential in structuring the research report. Very much correct. Okay. If you're very pukka in any one citation style and style manual, you can structure your research out in a beautiful manner. Value will get enhanced by standardizing the structure of research report. So this can be only partially true because structuring of report is one side, but actually the real content, what you have in your research paper will improve and enhance the value of your research. So A is true and R is partially true. Fine. Next, the citation indexes are now available online as Web of Science. Even Scopus is available. So both we can take Web of Science and Scopus as the online citation indexes. EBSCO is a different database, and JCCC, JGate Plus from Informatics India Limited, it's only an aggregator. They simply aggregate around 43,000 journals drawn from various publishers and they provide in a single platform. That is not a citation database. Okay, fine. Web impact factor is developed by, impact factor was devised by Eugene Garfield. Web impact factor is devised by P. Ingwersen, who developed the concept called webometrics. So very simple. Number of links to a particular website divided by number of pages available in that particular website. That is equal to web impact factor. The normal impact factor, we see how many articles, how many citations. In web impact factor, we have how many pages in a website and how many links are available to that particular website. It is called web impact factor. I think yesterday we saw, no, we have got in-link, external link, internal link, web impact factors, and all we can have. Okay, fine. Why to cite? So when you're writing a research paper, why should we cite others' papers? Okay, basically for acknowledging, you want to acknowledge, yes, I have taken this information only from this particular person. It's not my own content. So you're acknowledging. Crediting the original ideas. Yes, this is not my original idea. This credit of introducing this original idea goes to Mr. X. You are crediting. And thirdly, to substantiate findings. See, we have got some results, some findings. When you want to substantiate your finding, you need to show how others' findings are also similar to yours, or how others' findings are contrasting with yours. For that purpose, you have to cite. So A, B, C, all the three are answers. Okay, fine. I think this we have already discussed. Let me skip this particular question. Okay. Arrange the following according to their year of origin. Okay, APA, American Psychological Association, 1929. MLA, 1977. Chicago, 1906. And Turabian, 1937. This is a year of establishment. See, APA, it was started 1929. In fact, 6th edition was published in 2010. Now we are having 7th edition. It's a very wonderful book, 7th edition. MLA, it was published in 1977 first. Now we have 7th edition of MLA, which was published in 2009. And Chicago style of referencing and Throbbing style, both are published by same university, Chicago University. And Chicago style 16th edition was published in 2010. Durabian style 7th edition is presently in use. Fine. Okay. Here is a criticism by academicians and scientists on the use of impact factor as a measure of importance. Yes, of course, people are debating whether impact factor can be used to measure the relative importance. There's always criticizing. Do we have any other better measures? They are discussing. Impact factor is a general matrix and cannot be used to assess quality of individual research. That's exactly right. Impact factor is calculated only for that 27,000 plus journals which are indexed in Web of Science database. No other journal will have impact factor value. So both A and R are true. Fine. Which one of the following is not the feature of H index? Okay. So H index is mathematically very simple. It is very easy to calculate. Fine. Apply to any level of aggregation. So you can calculate H index for an individual, for a group of individuals called one department, or school of social sciences, or for one university, or for one district, or for one country. So at any level of aggregation, you can use H index, no problem. Then publications that are hardly ever cited don't influence it. So the papers which have not received more citations will not at all influence your H index at all. Only those papers which are having highest number of citations, only they will be influencing your H index score. So first three are the features of H index. The last one is not the feature. It is sensitive to performance change, something like that. Okay, fine. Which are the bibliometric law describes the frequency of publication by author, Lodcost law. You know it very well. Web of Science covers all subjects. We have science citation index. We have social sciences citation index. We have arts and humanities citation index. So all these three are covered in Web of Science. Okay, fine. Then comes metric-based evaluation is not suitable for assessing research performance of individual. We cannot say so because metric index is being used to measure the individual. We say H index, G index, M index, IT index, how many citations, total citation. All these are metric measures which we are employing at present to measure the research performance of individuals. So A is false. Then construction of citation profiles depend upon the databases used. Okay, so depending on the citation databases, you can create citation profiles. For example, if you're logging into Google profile, then you can create your own citation profile. So it depends on the kind of database, the kind of information they are giving you free. You can go and develop your own citation profiles. Okay, fine. Then H index lacks sensitivity to performance changes. That's what we discussed earlier. It's correct. It can never decrease. Same. H index will increase if you are getting more number of citations for continuously for your forthcoming papers. Your H index only will increase. It will never decrease. Okay. So R is correct. Okay. And A is also correct. But there is always a confusion on what is this performance changes. Okay. When a performance changes means whether they talk about the promotion or they talk about a number of papers, increase in papers. If a person increases number of papers, that will not have any impact on H index. But if he starts getting more number of citations for his papers, then his H index may increase. but it will never decrease. Okay, fine. Then, which are the following citation style manuals are from the same publisher? So both Durabian and Chicago, both are from the same university called Chicago University. Fine. Okay. Next, which are the following are the core content of ISI Web of Knowledge? So Web of Science called as Web of Knowledge. Now it is being taken over by Thomson Reuters, and now at present Clarivate Analytics is managing ISI Web of Knowledge. See, Web of Knowledge contains a good number of databases. So popular ones are, their service are current contents. Okay, it is a kind of alerting service from Clarivate Analytics. If you are subscribed to Web of Science, they will send you current content based on the subjects. That is service from Clarivate Analytics. Then comes ISI proceedings, all the very important conferences, seminars, webinars taking around the world are noted and they are abstracted and included in ISI proceedings. Fine. And thirdly, Derwent Information Index. See, Derwent is the world's very popular patent database. Okay, so you can access Derwent information database in Web of Science. So 1, 2, 3, all are the core content of Web of Knowledge. But the last one, no, Agricola. Agricola is a kind of online access database which is being maintained by US National Agricultural Library. It has got nothing to do with the ISI Web of Knowledge. Fine, good. Next one, arrange the following in the chronological order of their first era publication. So always science started first, 1964, Science Citation Index. Then comes Social Sciences, 1973. Then Arts and Humanities Index, 1978. And altogether, they changed the name, individual database, into a single combined name called Web of Science in 1997. Fine. This is the order of events. Then comes Off-Life Information Science. I think it's a repetition. Rate of obsolescence. I explained you already. Load cost law, once again, scientific productivity. Fine. The product of the relative frequency of occurrence of word and its rank is equivalent to constant. So that is what Zipf's law is all about. It is correct. The above statement is known as broad force law of scattering. That is wrong because this is a Zipf's law. Broad force law of scattering is something different where we talk about 1:n squared. We try to find out the core journals in a particular discipline. Okay, fine. So A is correct, but R is false. Then most of the institutions around the world use impact factors for measuring institutional productivity. I'm sorry. Impact factor is not used for measuring the impact of institutions. We are using only Hutch index for measuring the performance of institutions. Impact factor is used only for journals. So A is wrong. All articles published in an impact factor journal will be of equal quality. So we cannot say so. Okay, there will be always variations in the quality of articles published in impact factor. So both A and R are false. Okay, fine. Which are the following tools? Index cited references. So both Scopus and Google Scholar, they check all the cited references and they find out which paper is cited by which papers. That is what citation index is all about. So both Scopus and the Google Scholar, they index the cited references. Okay. JCCC is the aggregator service from Informatics India Limited, and DSpace is a open source digital library software from MIT. Okay, fine. Then match the following. Who coined all these terms? Statistical analysis, the earlier name of bibliometrics, was coined by Francis Cole. Statistical bibliography, a word coined by E.W. Holm. Bibliometrics was coined by Alan Pritchard. Librometry was coined by Dr. S.R. Ranganathan. Okay, fine. Then impact factor is the only method for evaluating the performance of an individual researcher. As I told you, impact factor cannot be used for measuring the research impact of an individual. So A is false. Then impact factor helps libraries in their journal subscription. This is true because whenever you want to purchase, subscribe to some journals, you will see the journals which are having the high impact factor because these journals are most influential journals. So you will be subscribing only to these journals. Okay, fine. Then bibliography coupling was first advocated by? Who advocated the concept of bibliography coupling? M. Kessler. Co-citation analysis, that was introduced by Henry Small in 1973. I think I explained the graph. What is the difference between bibliography coupling and co-citation analysis? Okay, that's clear to you. Next, what are the findings of Wilfredo Pareto study? So I was always telling about 80-20 principle called Pareto principle. See, what are the major findings of this Wilfredo Pareto study? They say they found out that small percentage of population accounted for a large proportion of wealth. 20% of the people, they are having 80% of wealth of the country. A is finding. B, 80% of results are due to 20% causes. So 80% of corona problems are because of 20% of the people. 80% of the problems in a school is because of 20% of the people. Fine. The next, large percentage of population accounted for a small portion of wealth. That is correct. Okay, when 80% of the wealth is in the hands of 20% people, okay, the remaining 20% of the wealth is in the hands of 80% of the people. So A, B, C, all the three are correct. The last one, 20% of the causes are responsible for 80% of quality problems. The ulta statement, the reverse statement. So D is not correct. Okay, fine. Then technical writing, style manuals and citation standards are essential in structuring the research report. Yes, true. The quality of research can be achieved only by standardizing the structure of a research report. This is wrong. Okay, I'm sorry, here is a mistake. This you convert into false. A is correct, R is false, because we cannot say that only by structuring a research report you can achieve the high quality of a research report. That is not possible. So A is right, R is wrong. Okay, I'll correct this and then I'll send the PDF to your Manoj sir. Then low cost law deals with productivity of authors in terms of scientific papers. One of the most repeatedly asked question, this one. Which are the following can be used to measure the research output of an individual? When you want to measure the research output of an individual, you can go for H index, you can go for G index. Okay, I think we discussed about both indices in yesterday or day for yesterday class. Benchmark is not a measure. Bookmarks are nothing but when you like a particular website, no, you create a bookmark for the particular website. It is called bookmarks. Benchmark is standard. So benchmarks are used for comparing two individual institutions on certain parameters. Okay, they are benchmarks. So H index and G index are two tools that can be used to measure the research impact of individuals. Okay, fine. A very known formula: if R is a rank of a word and F is its frequency, then R into F is equal to C. This is a formula of Zipf's law. You know very well. Okay. Then match the following. So impact factor. What is impact factor? Cited during the recent 2 years. Okay, in the recent 2 years, how many citations were there for your journal? That is impact factor. What is immediacy factor? I told you, if a journal is publishing papers in 2020, in 2020 itself, how many citations were received by that particular journal? That is called immediacy index. So immediacy factor is equal to cited during the current year, the same year of publication of the research paper. That is called immediacy factor. Okay, 2 hours. Then cited half-life, it talks about duration of citations to article in a journal. In a journal, for how many years the papers are getting half of its citation. That is called cited half-life of an individual article or an individual journal. What about this SNIP? It stands for source normalized impact factor per paper. Okay, see when you want to compare the relative importance of journals, you can take 2 journals and you can compare its impact factor. You can say that Nature is impact factor is around 4 point something, and other paper called Journal of International Computer Science is having 1.4 is the impact factor. So we can say that the journal which is having the highest impact factor is a very good journal. You can say no, but imagine One journal is from biology, the other journal is from computer science. How can you compare the impact factor of two journals that are from two different disciplines? So that may not be right, because in sciences, especially in biology, botany, computer science and all, the number of citations you get is more. But in the case of history article, you read a history article, you read a commerce, political science, psychology article, the number of citations you get in psychology and political science and history will be very, very less compared to science. So just by comparing the impact factor straight away, you cannot measure the relative importance of journals in a particular specific discipline, within one discipline. So what we say that in Scopus, they formulated a new concept called SNIP. That's called source normalized. Okay, here what they do is that citation based on the number of citations in the field. They take every particular field, agriculture, library science, engineering, they take field. Within that field, they find out the impact factor of each journal so that you can compare 2 or 3 journals in the same discipline. That is called SNIP, which is available free of cost from Scopus database called SciMago Journal Ranking. Okay, fine. I'll give a small explanation. You can read about SNIP when you are free. Okay, fine. This we have been discussing these abbreviations. Okay, you know this very well. Then according to APA style manual, a section at the end of the paper that includes information that is too detailed for the text of the paper itself and would burden the reader or be distracting or inappropriate. So what is that? It is called appendix. Okay, a section. Okay, this is the end of the paper. There we are giving lot of too many details. Whatever details you cannot put inside the text, you are taking all those things as the appendix. So appendix is described in this way by APA style manual. Okay, fine. Then which are the following does not come under the domain of descriptive bibliometrics? See, whenever you talk about bibliometrics, Alan Pritchard talks about 2 different branches. One is descriptive, another is evaluative. In the evaluative bibliometrics, we talk about usage counts, how many citations were received by the journals, usage count. In descriptive bibliometrics, we only describe, see, what is the various bibliographical formats, what are the various subjects, sub-subjects, what about the country, what about the language, what about the authors. So in general, we discuss, they are all descriptive. So geographical distribution of documents, subject distribution, medium means if you take one particular quantum of research output, how many journal articles, how many meeting abstracts, how many conference papers, how many editorial notes, how many letters, the different document types, no, they're called as medium of communication. So 1, 2, 4, they're all the different indicators, you can say, that are used in descriptive bibliometrics. Okay, fine. Half-life, I told you, half-life is something related to the rate of obsolescence of a particular research literature or a journal article or a journal. Okay, fine. A matching type once again. See, ARC ID, you might have heard about this, Open Researcher and Contributor ID. This is an author profile. Okay, when you want to create an online author profile, many author profiling systems are there. You have Google Scholar ID, you have Scopus ID, you have ARC ID, you have Publons ID, you have Vidwan ID, you have Kudos ID, you have Impact Factor ID. So many author profile systems are there. Then comes PLOS the Public Library of Science. Yeah, publisher who publish a very high impacted journals in the open access mode, especially in biology and biosciences. PLOS. So they are ALM, article level metrics. I think we discussed about it in Ultramatic section. How many people have viewed, downloaded, cited, tweeted, mentioned, discussed, researched about a particular individual article. ALM is article level metrics called article metric. Okay. Then comes social media citation. So how many times your paper, your research paper cited in Facebook, in Twitter, in LinkedIn, in WhatsApp. So that kind of analysis is called as altmetrics, alternative metrics. I think we discussed about it also. Then comes counter. So counter is a service from a leading, I think from JSTO, I think. So Counter, it is a software which can be embedded with your online subscribe e-resources. So that will tell you periodically how many journal articles, which journal is most used, most downloaded by your library users. So the Counter stat is very popular one. Fine. Okay. Then comes, which are the following research methods are used in a study of scattering of periodicals? Okay. So when we talk about scattering of periodicals, two things are there. Either you can take number of publications, okay, bibliometrics, or you can take number of citations. You can take some 1,000 journals in a particular discipline. You can arrange how many citations are received in every journal. You can divide them into 3 groups. So both based on the quantum of papers published or number of citations received, scattering law can be applied. Absolutely no problem. Okay. See, biobibliometrics something related to scientific study of individuals. Okay. So we talk about scientific study of one particular scientist, that is called biobibliometric study. Otherwise, it's called scientometric portrait. It's called scientometric portrait. You are studying the individual research impact. For example, scientometric portrait of a very famous scientist Narayana Murthy during 2001 to 2020. That is called a biobibliometric study. Okay, fine. Okay. Then match these things. Zotero is a online citation and reference management tool. The online version is called EZBib. EZBib is the online version of Zotero software. RG score is the ResearchGate score. If you are a member of ResearchGate, based on how influential your research paper, they will assign a score, RG score. Okay. Then NetFirst is the abstracting and indexing database of OCLC, Online Computer Library Center. And this Muktaboda is the digital library of Indology. So in America, there's an institute called Muktaboda Indological Research Institute. So what they are trying to do is that they are trying to digitize all the scriptures, all the valuable Sanskrit texts of India. So that library is called as Digital Library of Indology. Okay, fine. Okay, then in technical writing, style manuals and citation standards are essential in structuring and maintaining uniformity of research report. That's correct, because if both you and me, if both are following same style manual, there will be uniformity in presenting tables, in presenting headings, all things. So A is right. The quality of research can be achieved only by standardizing. So that is false. Okay, that's clear. Identify the frequency of occurrence and the analysis of co-occurrence of descriptors. I think we discussed already co-word analysis. Okay, fine. And once again, Zotero is a reference management tool, both online and offline. Item index was created by Google Scholar. Okay, Web of Science created impact factor. Scopus created Cite score. Okay. Scimago journal rank also was created by Scopus. Okay. The G index was proposed by Leo Eggy. So Leo Eggy is the person. George Hirsch proposed H index. Only person developed Bibliography software. Okay, fine. What is epilogue in a thesis? So if you take a thesis, the final chapter of the research report is called epilogue, where you give all your findings and your perspection about the research findings. That is called epilogue in a thesis. Fine. Which are the following are reference style management tools? Okay, here Mendeley, Zotero, Refox. All these three are reference style management tools. Stata is a statistical package which was developed by Stata Corporation long back in 1985, written in C language. So Mendeley, Refox, and Zotero are reference style management tools. Fine. Who is the creator of R statistics? Rose Inaka and Robert Gentleman from Bell Laboratories. Fine. Altmetric is not related to, I think when I was teaching you about altmetrics, I told you four things. One is frequency of occurrence, then record of attention, measure of dissemination, an indicator of influence and impact. Okay, so 2, 3, 4. These three are the features of altmetrics. A record of bibliographical data on a subject. This is not at all related to altmetric. Okay, fine. I think we have reached the fake end of the question paper. Which one of the following measures the impact of scholarship and research through online interaction. How many people tweeted, how many are placed, how many liked, how many downloaded, how many tweeted. It is called alt metrics. Okay, fine. Then you have to match these three things. You know very well. Broad force law is about law of scattering. Load cost law about author productivity. Zipf's law is about occurrence of words. And Eugene Garfield, he talked about law of concentration. That's the number of journals divided by journal citations. See, this gentleman, Eugene Garfield, something very close to broad force law of scattering. He found that if you take a case of a multidisciplinary field, only very few journals, they have publications that have received a good number of maximum number of citation. So that small number of journals that contribute most number of citations are in the law of concentration. Fine. Okay, good. So that's about questions on these two topics. So I think the floor is open for discussion. If you want to ask any question on all these areas, you're most welcome. I will send both these PDF files to Manoj sir. He in turn will forward these two PDF files to you. Okay. So you can ask your questions. Before that, let me thank you for being very patient in all these my classes. And thank you so much for all your patient listening and interaction. Thank you so much. Now time for questions.
Thank you, sir.
Yes, somebody
Sir, no
ask a
question.
question. Yeah?
Yes, sir.
Yes, please ask your question, Rania.
Sir, Sotoro is a bibliographic reference management system or reference management system, which is correct, sir?
And actually, you can say that Zotero is a reference management software. Okay. See, when you say bibliographical, it means books, then newspapers, then journals, then conference papers. These are all called bibliographical entities. See, what about a video interview? What about a blog post? What about a website? So if you are preparing a reference for these things, then you cannot say that it is a bibliographic. So you can say that Zotero is a reference management system that can provide you references not only for bibliographical entities, but also for non-bibliographical entities also. Okay, Ramya?
Okay, sir.
I think Ramya asked only one question in my entire session. Thank you, Ramya, for that question. Okay, any other question from other participants, please?
Sir, I have one more doubt.
Please go ahead, Ramya, please.
Sir, log.ca citation, op.cite, I can understand.
Oh, it's very, very simple, yeah. See, for example, there is a paper written by Ramya. Okay, Ramya has written a paper on internet use habits of college students. Okay, Ramya has written a paper. In 2020, you wrote a paper. Okay. Now, as Ramasamy, I am writing a paper on internet use habits of college students of Tamil Nadu. I am doing a research study. In my research paper, I want to take some content from your research paper and I want to add it. Where do I add? Introduction part or review section or finding section or discussion section? I add your paper. Okay. For example, when I am discussing my findings, I take one reference from your paper. Okay. So I will write Ramya within bracket 2020 wrote this. That is first reference. In the second time also, I am referring your own paper. Same paper, your paper, I am referring again. So when I am using your own paper,
Sir,
immediately once again.
Sir,
Yes,
what is the difference between these two?
That's what I am telling. Sarika, that's what I am telling. That's what I am telling. Okay. Okay. So if I am using Ramya's paper, again I am using Ramya's paper, you can use IBID. Very clear. Okay. Okay. Then I am using Ramya's paper first. Then next I am using Sarika's paper. And third I want to use Ramya's paper. The third item when I want to refer to Ramya's paper, if I am referring to same page what I referred previously, that is called loc.cit. Okay. Or the third time you want to refer to Ramya's paper, but you want to refer to some other pages, then that is called op.cit. Only difference between IBID and LOC-OP is that in between two papers, you are referring to Ramya's paper. Once again, you are referring to Ramya's paper, but in between some other references are there. That time, either you can go for loc.cat or op.cat. If you are referring to same page number, go for loc. If you are referring to same reference but some other page number, then you can go for op.cat. Is it clear, Ramya and Sarika?
Thank you, sir.
Thank you, sir.
Okay.
Yes, sir.
Okay,
Yes,
very
sir.
good, very good. Any other question, please? So no other question?
No, no, sir. No.
Okay, okay. So I wish you all the best. Okay, on behalf of Educare and on my own best personal behalf, I wish all of you that you all will clear UGC with a very high score. My best wishes. Thank you so much.
Sir,
Yes, please, Sarika.
sir, our UGC net exam, which month will it come? You know,
It will
sir.
come maybe once the lockdown period is over. No, they may start because lockdown may be extended for a few more months at least up to June. It will be there. Maybe in the month of July we can expect. Okay.
Okay, sir. Okay.
Okay. Bye bye. Take care. All the best. Thank you so much. Take care. Yes, Sinju, tell
Thank you,
me.
sir. Thank
Sinju,
you,
tell
sir.
me. Okay. Thank you, Amro. Thank you for all your technical support. And thank you, Manoj sir, for this wonderful opportunity. Thank you so much.